you know, they had left something in the basement. That's all they alluded to. And there was a dark room.
Yeah. Maybe you can just do a little start. I don't. Maybe just your chair, pull it in front, so we can make a nice
A little more of it. Yeah, I like that.
So we can see each other.
Oh, you have notes. Oh man, I didn't write any notes.
Well, that's because you got it.
But
The master of winging.
Check.
Yeah, down here at the bottom.
Ah, look at you.
hello.
All right. Everyone's mic's working. Let's give it a test. Good.
Test.
All right, we're going to get started here just in a minute. So let's give it a few seconds and hit it off.
So you think they trashed it looking for the treasure?
No, they were just looking for anything of value. So if it was holdable ball and it looked like they wanted it, they were just like, ball. If it was garbage,
All right. Well, good morning, Pittsburgh. It's amazing to be back here at the Robotics and AI Discovery Day 2025. We have had some amazing couple of panels before this one, and we have one more coming up, and we're going to try our best to match them or even go higher. So what we'll start with is a few introductions, just a little bit about who we are, about our companies, the experiences in the field, and the mission statement that we have in our companies towards robotics and AI. The panel that we have today is Powering Progress, the business of supporting robotics and AI. Essentially, we'll cover a lot of topics about how our companies are building a tight ecosystem within the space of robotics and AI that enables the businesses developing technologies and product to accelerate and move faster. So I'll do a quick introduction on my end. My name is Sahil. I'm the VP of Product and Partnerships at Digital Divide Data. There's a little bit of typo here, so don't worry about that. It's Digital Divide Data. So we are essentially a human-in-the-loop data operations and data engineering services company operating globally, within US, Africa, Southeast Asia, and so on. So we work within the space of autonomy, robotics, MLCV, providing data operations on anything that essentially has to do with taking the raw data and converting into an actionable insight for product development. That's what we're involved with. So I would request all the panelists to do a quick introduction, and we can take it from there. Thank you.
My name is Matt Beale. I'm the president of Daedalus. Daedalus is a product development firm that's been in this Pittsburgh market for 45 years. We didn't do our first robotics project until the early 90s. Since then, we've done dozens of projects, almost always in our verticals of healthcare, safety, and biomedical. But we're open to a lot of interesting things. We have a tendency to only work in our specialty areas outside of the region, but we'll stretch and do some unusual things locally, which is a lot of fun for us.
Hi, I'm Brian. I'm the founder and CEO of a company called Hellbender. We're a 4-year-old company that does product design and manufacturing for computer vision solutions and edge AI devices. So kind of the eyes and brains of getting what's happening right now in the cloud out into a device and then manufacturing it. So we do our own printed circuit board assembly and box build. We've shipped about 44,000 devices in our first 4 years, and we do all that right here in Pittsburgh.
Hey, I'm Chris Matthieu. Very nice to be here. I'm the Vice President of Developer Ecosystem for RealSense. You might remember RealSense with Intel. We've spun out. We're our own company now. We're the stereo vision robotics eyes company. Over half of the robots in the world use RealSense cameras for stereo depth. So kind of like humans have 2 eyes, most of us. The robots have 2 eyes. They can see depth and distance. And they call me the chief hacker. So I've been a developer my whole life. I love developers, and all of our SDKs are open source, and I love robots.
Hello, my name is Aaron Morris. I am the innovation principal at a company called Woolpert. I heard some ages. I think I've got you all beat. Woolpert is over 100 years old. Our origins are in survey, but we have since become a high-tech map maker. So our industry is architecture, engineering, and geospatial with a big emphasis on the G. We fly planes with all kinds of sensors. So if you've been on USGS websites and looked at topographic maps, we provide those. We also do asset inventories, high-definition mapping. So a lot of the support infrastructure for autonomous systems use our technology to navigate.
Awesome. Well, thank you, everyone. Well, we are seeing so much innovation, around here. Especially, I mean, if you peek around in all these different sections, everyone has something different to exhibit and showcase, what they're doing, right? I mean, especially if you talk about Pittsburgh, we go all the way to early 2000s. We talk all the time about the, the Grand DARPA Challenge, coming all the way to now, which is 2025. This innovation is not a one-step, one data point problem, right? I think there have been a lot of inflection points in the last several years where you have gone, the rate has increased, you're more accelerating over time. One of the things which I would love for this panel to address about is this innovation and the product development is pretty intensive, right? Whether it's from a capital standpoint or the overall effort that gets put down. So it's not a one-player problem, right? You need to be collaborative. You need to be pretty. You need to build the intermesh, which I call it, for different partnerships. So would love to get perspectives from everyone here. No particular sequence is. How are you using, let's say, AI or some of these new deep tech in building these partnerships within your space? If you can give a couple of examples, just how is that working for you with you and your clients? Anyone?
I guess I'll give that a shot. So we are using LLM type AI in our everyday work. We have not been applying that in the products that we develop for our clients. The AI work we do in that area tends to be more in the machine learning, deterministic area. We do AI, we make sure there's a deterministic layer, or we have a checkpoint that is human to make sure that any potential errors can be caught by the individual who's working with the system. But we are doing things with visualization, we are generating code, we are processing lots and lots of data, and we're finding that. And we're also using AI to just read huge documents and identify important points. So it's part of our everyday routine, but we haven't launched a product that's driven by an LLM yet.
Yeah, so I came into Woolpert actually. Well, a large part of what I do there is kind of lead their AI efforts and strategy. In fact, I actually started a company called All Vision, which became part of Woolpert, and our whole thesis was taking autonomous vehicle data, so this really rich LiDAR and camera data, and autonomous vehicles use it to obviously make maps and navigate. But there's a lot of problems if you're a city, a municipality, a parking authority, which you need to know where your infrastructure is at. And so we stepped into that to mine this data to find these assets at scale. Because one thing you're going to start to see when you talk about geospatial is we're not mapping. I mean, even to map this, this area would be significant. But we're talking about city, county, state, even country level. And when you're trying to find small artifacts at that scale, you can't. You can try to do it manually, but really AI is the enabler for you to do that kind of analysis very efficiently.
Yeah, I would add to that too. One thing I'm really pleasantly surprised about is there's a lot of open source in robotics. So if you look at ROS, the robot operating system, you look at the RealSense camera developer SDK, it's all open source. I vibe code. I've been hacking for 40 years, but maybe I'm a really bad hacker, but I think it's getting better than me. At the last event, I gave a talk. I was going to build a follow me robot from scratch. It had the wheels and everything on it, but nothing else. Ed Ross. I had 30 minutes to build a follow me robot, and I vibe coded this thing on stage. I kid you not, 10 minutes I was done. So we were asking, what else do you want it to do? And AI was writing all of that code. A lot of it's open source. It was able to reference examples. I think it's amazing how fast all of this industry is moving.
Yeah, what I'll add is, most of what we do, about 90% of the products that we make are moving AI out of the cloud and onto device. And one of the reasons why people are doing that is because your communications and your data costs are high, and most of us here are all about robotics, and so you need to keep that latency down as low as possible. And there aren't a ton of tool sets right now that are really leveraging models deployed, on device. You have kind of the NVIDIA ecosystem on floating point GPUs, and then on the extreme low cost end, you have these ASICs, and you have these neural processor units, these neuromorphic AI accelerators. But the challenge to deploy them, the tool sets really haven't caught up yet. So even though we have a lot of our clients are trying to move out of the cloud and onto device, for a number of different reasons, like, we see that there's still a little bit of a gap on how to deploy non-floating point to integer based on these chips. But then that lets you get your cost of like an NVIDIA GPU from $230 down to this $15 or $20 AI accelerator ASIC.
So one point I picked up from this conversation, I want to make sure we kind of go a little bit into that, is we're all using AI, to some extent from the initial inception to actual, like even to the point of deployment. The questions that we get, like my background is in autonomous vehicles, and a lot of times the question is about verifiability of AI, and how do you make sure when you have a critical application that's going to be deployed to the field, like how do you verify some of that? So given your experiences, I think Matt, you talked about some of the safety critical applications where you need to be a lot more deterministic. I mean, you can't, like 1 centimeter move of a robotic arm in a surgery can cost you, will have very serious implications. What is your experiences been, or how are you putting those guardrails in using AI assistants when building safety critical applications? What is the sense collectively from this panel? Anyone?
Yeah, I guess I'll jump in since I'm sitting closest to you. This idea of using probabilistic AI and then having deterministic layers that has a set of rules to determine whether the findings are accurate is one piece. But I have to say we do lean on quite a bit something that we've always leaned on in medical device product development, and that is the human's ability to make decisions. So if we can create a system that always creates whatever's the least risky thing, a false positive or a false negative, and no false negatives or no false positives, depending on what the objective is, and that information is presented to the end user for a decision, the decision making can be sped up, but the ultimate responsibility remains with an expert. We have the benefit of working in fields where most of the people who use our products are trained, and because of that, we can enable them to make better decisions and know that they'll be able to use that information successfully.
Yeah, I can add to that too. NVIDIA recently released something called Holoscan Sensor Bridge, and what that does is it takes all your sensor inputs over Ethernet directly to the GPU. So we have that running on our RealSense cameras now. I think the time is 17 milliseconds to go from total vision, red, green, blue, depth, all that pixel technology to a GPU. So if you add what Brian said about LLMs, VLMs, VLAs, action models on the GPU, you're talking instantaneous, like sensor to brain, like technology. We've all seen these humanoids a little frustrated that they move kind of like robots. Like they kind of move really slow, and like if they try to pick something up, it's like, let me just grab it for you, you're too slow. But what that's gonna enable them to do is more fluid movement. The cameras are doing 90 frames a second, so they have all the data. They just have to compute a little bit faster on what they're trying to do and safer.
Yeah, and I will also say that like I've been in the AI data mining for even before it was cool. And I think a lot of people think about this as like the LLM, where I ask it a question, it just spits out something maybe like 80% of it's right, and I don't know, and then I'll just run with it. That is never how we've architected our solutions, because when we provide a deliverable to a client, it has to be 100% correct. You know, even 99. And so it's how you implement AI, and you know, we've always used that as an enabler to streamline what are traditionally manual workflows. And in fact, what we've found is, like, even while AI is a benefit, it's actually the good hygiene, data hygiene, if you will, surrounding it, that I think also is beneficial. Because, you know, when you step into an organization and you have to have data. Where's your data? Well, it's on a hard drive over there, and then well, that's not helpful at all. So we've got to create a database. We've got to organize. We've got to name. And so it kind of forces good data architecture, good data habits. And so it's I think the whole system that really shows the benefit of AI, but also, you know, provides the sanity check on just making sure that, you know, stuff doesn't go out the door.
Yeah, and some of the typical concepts that you see that a lot of the companies here are using on their robotic implementations is that they're going to abstract away, put guardrails in with a safety-rated microcontroller that acts as a watchdog system, and they're going to do a risk analysis for, you know, criticality and probability of what something's going to happen, and then those are the things that, you know, you put those deterministic layers around, so that if you've got, you know, a Thorough AI's 1.8 meter per second industrial floor scrubber that runs in a school where, you know, your 9-year-old's running around, it's, you know, there's a layer of protection in, you know, at a functional safety layer that can interrupt and prevent something bad from happening. But again, if you're in an industrial environment, you're in a warehouse, you're in something where there's mandatory training for personnel that's on site, you know, then those safeguards can move a little bit outside of the robot and be imposed procedurally on that infrastructure. But you can't do that when you're making robots that are out in space and being service-oriented or public-facing. And so you just have to understand that mix that you're trying to accomplish and what your risk tolerance is.
I think people are learning too around safety. Like we're all talking about speeding up the robot's intelligence so that it can detect an issue sooner. But like, you can't just stop a humanoid. Like, if it's going to happen, it might be in a position that gravity takes over. You know, so they have to like collapse. Like, they have to kind of squat or something. Like, we're learning as we go to make these robots safer.
Yeah, we used to call them minimum risk maneuvers, so want to make sure you have a minimum risk in whatever action you take. But perfect, right? I think this is where we talk about, like, we have some guardrails, we have kill switches, we want to make sure the output is, you know, much deterministic, that goes out to the client, and, you know, depending on the criticality. Like, for example, I was wipe coding earlier in the morning to do a quick, you know, build an application, and without even spending any time reading the script, I was able to do what I need to do. But that's less critical compared to deploying a surgical robot. Perfect. Next section we're going to quickly go into is, you know, we have seen a massive evolution when it comes to AI-based, like, robotic systems, right? So all the way from your initial automation, like simple heuristics, to perception-based systems, to now where we are with, you know, generative and agentic AI. I mean, you can see it, you know, massively evolving in the last, especially taking off in the last, you know, few years. So my question to the panel is, you know, based on your customers and your clients, assuming their needs are also changing because what the fields that they are in and how competitive they want to be in this space, how are you adapting to this curve of technology, you know, kind of moving rapidly up? Are you making any certain engineering, business, product decisions that are helping you to guide through this evolution? Like, maybe share a little bit of insights around that.
I think that for us, we're focused on things that can be implemented in a product that is in people's hands, usually in 6 to 12 months from when we start a product. So a lot of our actual project work is very focused on what is possible today, what can you buy off the shelf, what can you quickly adapt to a particular purpose. But our own internal sort of training and research goes beyond that. And we have benefited from identifying what's next and being able to service mainstream companies that are not at the cutting edge in those areas. So whether it was basic computing going into a particular device in a particular industry, to touchscreen computers, to Internet of Things, to AI and machine learning, that's where we try to be, and understanding what is possible in 6 months to 12 years has been really key to us.
I'd say on our side, we, since we also do the manufacturing, there's a large element of picking the right suppliers who are moving correctly in space, and they're taking serious advantage of these new developments. So for us, we've got a great partnership with NVIDIA. We've got a fantastic partnership with Halo, a low-cost AI accelerator chip company, and with Raspberry Pi. And Raspberry Pi is probably in the bulk of the products that we ship out there. And a lot of people think about them as principally like a STEM function, but 90% of what they put out now is their custom silicon, and it's going into industrial applications and commercial applications. So it's it's not just for education and hackers anymore. And really, those close partnerships where we're contributing back to the code bases of our suppliers and helping feed and push what we want to see happen with the next era of silicon, because it takes 2 to 4 years to make changes to an ASIC, make changes in silicon and get it out there. And the speed and the rate of change of what we're seeing, in these different, VLAs, VLMs, SLMs that you're going to deploy, that pace of change is so fast right now that it's significantly staying ahead of this traditional ASIC and silicon development curve. So it's important to be partnering and using chips out of those ecosystems that are leaning into the speed, and they're trying to find ways themselves of accelerating time to market, so that we can take advantage and our customers can take advantage of these great emerging technologies.
I would say for RealSense, we're seeing, I feel like we mastered AMRs, autonomous mobile robots with wheels. I'd say we've mastered the arms, the stationary arms. The shift to humanoids is opening up a whole new way of thinking about vision and perception, for us anyway, in robotics. And what I mean by that is like the AMRs, you do odometry based on wheel ticks, wheel clicks. So you're tracking left, right wheel movements, and humanoids don't have wheels, or quadrupeds don't have wheels. So now you're doing visual odometry, like where am I at in IMUs, like where am I at, where am I turning? Another interesting thing is like an AMR might only have 4 cameras, front, back, left, right, like Spot. That Spot dog that's walking around has got 5 of our cameras on it. But if you look at Digit, the agility humanoid, he's got 7 of our cameras. So they have a lot more like to look at. The arms sometimes need a camera on each arm to see what they're grabbing. And one other thing that I kind of went, duh. I was looking at it, it's like a robot, when it moves its arm, it might not see Brian there anymore because its arm is occluding its vision. So now you got to take that into consideration, where an AMR had full 360 visibility. So things are changing for the better. I think it's really an exciting time to be in this space.
Maybe just a follow-up there for you, Chris. You mentioned the VLAs and VLMs a couple of times, right? I think, what is your experience been so far when it comes to, like, you work with a whole bunch of clients, who are building these products, like you have Agility, you have a bunch, in the Bay Area and so on. Are they open to sharing their data insights back to you so that impacts your product development? Or like, how is that bi-directional sharing of intelligence happening for your, I mean, it can be generalized, but
you touched on my favorite topic, and Brian was going there. The way I vibe coded that robot at the last conference, that's old school. Like, you don't like programming ROS anymore. I'm seeing a trend. Like, you're going to give a robot a mission, and it's running these LLMs or VLMs, vision language models, on the robot. So you want to get as fast as possible on the GPUs. So you say, do you see a human? It's like, yeah, I see four humans, okay? So then it says 5 humans, right? I see 5. I see a lot more humans out there. But then you say, okay, now you need to follow the human. Well, it's returning ROS twist commands like from the action model that's then talking to the motor. So it's like putting the LLM AI brain, giving it wheels or legs or whatever, and it's figuring things out. Remember the movie Matrix, where Neo goes, I know Kung Fu. Well, the robots, they see a screwdriver, and they're like, I know how to use a screwdriver. So it's this mission-based VLM, VLA movement in physical AI, Jensen calls it, embodied AI, physical AI. That's what we're all seeing next.
We are a little bit different in that, a lot of our customers, again, when you are the map maker, you trust that map. And for those, again, I now live and die by my navigation apps. I'm the blue dot on a line somewhere. And so that has to be right. If you take a turn and that's not where you want to be, that's not good. So from our standpoint, again, we internalize AI to provide these data sets and these maps that are just, you assume are to be accurate and true and go out there. And the other side of this conversation, though, I found is interesting is, again, not only were we developing it, but, we're leveraging platforms. But as a company like Woolpert, a lot of our IP is our processes, is our how we came up with this map, how we came up with this deliverable, and by incorporating these platforms, you're more or less encoding the knowledge and expertise base of your internal teams. So you've got to be cautious about like what platforms you're using, how they're using it, how those models are being trained. So we're always kind of pay a lot of attention to the platforms that we use to do these data product deliverables.
Okay, great. We have a few minutes to go, so I want to make sure we go into the last segment. So I think the last couple of panels, maybe the first one touched on human in the loop aspect of things, right? Like we are really good at strategizing, having a vision, moving up in the reasoning chain. Now we know that the artificial general intelligence is a thing that's going to come down, and that's probably going to help with a lot of these things, and I think that's great. But where in your value chain as an organization, how are you shifting the ladders of human involvement up as AI and robotics? They're kind of taking those initial steps of kind of robotic automation, or if you want to call agentic automation. Is there some change that you guys are making within your organizations or within your field of expertise where humans are still, they're in charge of the top line decision making? Maybe share an example or two if you can. Just
it's a complicated set of decisions that are involved. So for us, we tend to be ambitious initially and paint a picture or even build a prototype where the system is making more decisions without human involvement. And then we can make recommendations within our organization based on human factors and ergonomics and what the risk of, what a failure might cause. But we can't make a decision based on sort of legal, insurance, risk, and that's when we start to integrate with our clients on those decisions. So in some cases, pushing a decision to a machine might be the more responsible thing to do, but it may be a higher risk decision from a regulatory or legal standpoint. Now that's not a decision I'm capable of making, but our client teams are. So we typically kind of push, and then we say, here's where we think we could step back to and make a reasonable system. And then our clients will sometimes pull us back further. Sometimes we're completely in sync.
I think we're still seeing a lot of teleop, like humans controlling, teaching, robots, all sorts of things. In fact, there's a new trend of humanoid boxing. I don't know if you guys have been watching humanoid boxing. Guys on both sides of the ring put on VR and the controllers, and they're sending their unitaries or whatever into the ring and fighting MMA, like mixed martial art fighting. So they're teaching robots how to fight. But what I also see is in simulation, that's also on another trajectory on itself. You can run millions of simulations on maybe how to fight better without a human teaching it. But I think the two combined is going to get us to a lot of this AGI understanding the kinetics of its own body.
Yeah, well, you said simulation, and that got me a little off topic in that I remember when I was a grad student. First off, your example about 10-minute coding was incredible because the rite of passage of a grad student at the Robotics Institute at Carnegie Mellon University in the early 2000s was writing your own operating system. So that was your passage. But we had a phrase called, simulations were doomed to succeed. Like if you didn't, the world was its own best model, but to run lots and lots of iterations of whatever behaviors you wanted to test, you would use synthetic environments, and you could make it work really well in that environment. But the moment you put it out in the real world, it did whatever it was going to do. And so, and that's again coming back to what we are all about at Wolpert is digitizing the real world, and making sure that when we're using these simulators, that you have the highest fidelity, most accurate representation of real world conditions.
One thing about simulation, I know we're running late, is that the simulation is too perfect. Like, so we're adding fuzziness into the cameras, like to mimic real world, to make simulation more effective when you unplug it, when you turn it loose.
Similarly, we are, you were using visualizations or simulations. Initially, a few years ago, we were using renderings that were generated, photoreal renderings of objects in the machine, but making those renderings bad as well as really, really good. So they'd be even worse than what might be encountered in the real world. And then we started to use the Unreal Engine to generate scenarios or dynamic simulations. But the problem that we had that pushed us into that was we couldn't get enough objects. The manual throughput of objects was extremely time consuming. And when we started to get into dynamic behaviors, we started with like a huge collection of videos from sites where these activities took place. But the activities that we were most interested in were extremely rare, and dangerous. So we couldn't even ask people to simulate them in the real world. But again, that fuzziness, that bad lighting, that sideways or upside down or terrible angle, all those things, you got to do it. Bad is good, for sure.
I got to say something about simulation because that's close to me as well. So I think it's like, you hear a lot of times, okay, you can simulate, you can have synthetic data, you can have these variations. I think simulation does a great job when you talk about edge cases where there is already enough noise in the system that you can't differentiate between an original scenario and a simulated one. But when it comes to realistic, simple scenario and having that to be first, I think that's a challenge which I think a lot of companies are tackling pretty actively. With that being said, we are minus time here. Closing comments from all of us, maybe starting from Aaron all the way. Tell us about what you thought today's panel was, and just your booth number as well, if you have an experience.
Well, first off, I appreciate being partaking in this. I couldn't have picked a better session theme-wise. I'll close on a little story. Again, back in the grad student days when I worked for a gentleman called Red Whitaker. A lot of people know that name, but as you reach the end of your doctorate, you're writing your own grants, and I'm writing grants for all kinds of tunnel mapping and various programs, and it dawned on me that none of these things are asking for robots, not a one, right? They're all asking for data or maps, and then I was also at the early point of the autonomous vehicle. DARPA Grand Challenge, Urban Challenge, and then you would just see teams of people digitizing roads to enable the robot, the entries to drive. And so it dawned on me then that like part of this infrastructure to support robotics and AI is going to be built on a solid foundation of maps and digital representations of the real world. So that set my career, and that's what I've been working, to this day to make real.
Like Aaron, I would say thank you for everybody, your attention here. If you want to learn more about RealSense, computer vision, AI, robotics, we're at booth 314.
Yeah, this is a fun panel, but what I'd say, if you guys heard terms, I think all of us are probably pretty technically clear. If you heard terms that you're not familiar with, the barrier to entry has never been lower. Like to go out and hack something together, either yourself in your spare time or with your kids, and get curious again, because at the end of the day, like there's some real excitement, and these tool chains are moving very, very quickly. So every 90 days, there's just this complete overhaul of what we can do and how small we can make models and how big and effective that these models can put things out. So I encourage everybody to just go out and explore and make.
I'm going to step back real quickly to the previous session because I kept thinking of answers on how to apply for jobs and how to manage your career. So, yeah, I'm looking for a job. So if you were looking for like an older guy anyway, I think that if you're early in your career or late in your career, if you can maintain an understanding of where the edges of your knowledge is and who's on the other side or what is on the other side, and what your strategy is for growing your knowledge and where. Is your strategy you know somebody? Is your strategy you learn something? Is your strategy you know a company or you know a resource, right? So knowing those edges of your own knowledge is super clear. If you could make that clear to someone on an interview, that would be a remarkable help for them. The other thing I would say is the other edge that's really interesting is what can be done with technology now, what can be done with technology in a year, what can be done in technology for 10 years, and what is that barrier? Is it cost? Is it performance? Is it reliability? So knowing about that edge, that frontier, is incredibly useful. And I think that second one is one I only figured out in the last 5 years that I really, really need to know. And of course, many of these innovators that have changed the world have been extremely aware of the frontier, and the moment a new material or a production process enables that future, they are ready to go. And most of us are just waiting for someone else to figure out how to do it.
Very well said. I appreciate that. Everyone, again, thank you so much for this talk. Thank you to all the panelists again. We're open for questions. So if you have any questions about the topic or career counseling as well, Matt is here to answer. But we have open for questions. We have a mic that's going around if anyone has anything to ask. We have one question here. Do we have a mic on the floor?
I think there's a mic in the middle. Yeah, there's one right in the middle.
I can just give you this one for now.
So I didn't hear anything about security in the development of these systems, especially composite systems that are taking pieces from here and pieces from here and pieces from here and have to do things that are human safe. I'm wondering if you could comment on that. Thank you.
So there's I'll jump in first. So when you're thinking about security and cybersecurity, there's a couple different layers to it. Like the first is, protecting data, protecting the output, and then the second is preventing somebody else from creating some malicious action, particularly if we're talking about like a robot that's out there. At the end of the day, security is just the same on electronics as it is physically. You take a layered approach. For us, our company at Hellbender, we use third-party cybersecurity consultants depending on which industry we're supporting. If we're doing something in medical and we have a series of things that are deployed in hospitals right now, then there are different requirements that you need to hit. But at the end of the day, you're always going to have a physical perimeter boundary that you put on your device. Now we're lucky in that we make edge devices that for the most part we're taking care of a lot of GDPR protections and things right on device. So we don't store video at rest and we don't transmit video in the large majority of our products. We're consuming it, using it in that NPU, that ASIC, like we're determining what it is, and then we're changing it to ones and zeros, and then putting it out. And so depending on the environment that you're in, the industry, and the regulations that are appropriate, you're going to come up with a layered approach and bring in the right skill sets and folks that can evoke the outcome that you want.
Totally agree with Brian, but there's one new news announcement that's causing a lot of controversy. I don't know if you've seen the Neo robots, the humanoids. They just released. You can pre-order them now, $500 a month, or you can buy it for $20,000. But the controversy is that they're teleoperated remotely to help you solve problems in your house. So now you got some guy, some stranger loading your dishwasher with a robot remote controlled in your house. So it's secure, technically, like hardware, but there's someone looking through its eyes and moving its arms. I don't know. That's kind of creepy.
It's only temporary. We'll have that all taken care of.
Yeah, I'll be worked out in the future.
Pay no attention to the man behind the curtain. Yeah.
All right, let's take one more question and then we can. There's one more right here. Okay, there's a mic. Perfect. Thank you.
So if a manufacturing company has a lot of manual processes, but we want to scale quickly, which we do, what's the best tool to integrate the capabilities of robotics? In other words, we want to take this from a manual process to automated with the capabilities of AI. Is there a specific tool that would help a manufacturing company integrate the AI capabilities with those of robotics?
I'll take the first stab at that if the panel doesn't mind. So I think the first thing is Especially if you're in Western Pennsylvania, sir, there are a lot of resources that are available within our community to help you with that and to offset the cost. So the Advanced Robotics Manufacturing Institute, founded by Carnegie Mellon University, this is a 300 plus member coalition that if you bring your problem to them, then they have a lab run by a great engineer I used to work with, Bill Miller, who will take a look at the problem set. Now, if you happen to be in Armstrong County, like out in New Kensington, there's a whole dedicated lab that does that for you, and it's a free service to small businesses and manufacturers. Us internally, we do a lot of box build and a lot of assembly in our shop. What we did was we ended up creating a robotic work cell, cobot work cell, around a Universal Robotics 3E arm, leveraging the NVIDIA Isaac manipulator library, and then it's very fast to train up, take that same footprint and then train it up over and over again. So I have 13 of an identical work cell with different tools, but it's all identical arms, all leveraging the NVIDIA Isaac manipulator platform. And then we just changed the fixturing based on what we're trying to accomplish. And I'd be happy to chat with you about what our experience with that has been.
I would add too, I think what the trend is specialized robots today. Like if you've got an arm that's going to just do things like this, that's fast and easy. AMRs where you need but the new direction is a lot of humanoids, cobot working together. I would say start simple. Find something where you get a good value, bang for the buck on solving. Start simple, validate, and just progressively move to the next simple challenge.
Well, I will take that one, and again, because we tend to focus on the tool, give me the thing, and Brian, those are great resources, by the way. We tend to focus on that tool, that thing, but I can tell you right now, if you want to have a successful outcome, kind of adjacent to what you're talking about, the process is so important. Go into it with define your expectations. A lot of people are like, I need AI, or I need this automation, and they'll just throw a bunch of people at it, throw some money at it, and in the end, they don't get what they want. And then they're unhappy with it, and it sours, I think a bad taste for it. So make sure that when you're implementing these things, there's a very clear goal, objective. You have metrics that you can track, you can measure, and that you're looking at those throughout the implementation, and that you can define and you can see success. Like, it's so important when you're putting these practices or these automation and tools in practice.
I'd add one more element to that, which is just you're going to then feed back into your design process and your client's design processes so that you're designing for robotic manufacturing and robotic assistance as you're going through it. And then frequently what we did was we just had to change the way that we design products to really leverage those goods.
We are super over time. Maybe last comment, want to make sure the other panel comes on stage. So
okay, Don, I know a little bit about what you're doing. One of the things I will say is that as much as robots, AI are cutting edge, right? Industrial robots are not cutting edge. They've been around forever. And longer than my career, we've had industrial automation. And I think that what you're doing, you may be able to look at things that are going on in food service to understand what is applicable to your particular problem, which has a unique irregularity to it, I guess I would say, in terms of your inputs. So food service automation is I think it would be a great resource, and there are people in this region who do that.
Awesome. Well, I want to thank everyone again for staying extra time here. And if you have any more questions, we're going to be standing just right here for a quick chat. Again, thank you to all the panelists, and thank you to Pittsburgh Robotics Network, everyone here. And cheers. Enjoy your day.
Thank you.
Thank you.